Good afternoon and welcome to the 2018 New England Greenhouse webinars. My name is Jeffrey Jue from University of Massachusetts Extension, and my co-host today is Rosa Rodales from University of Connecticut. The webinar series is a cooperative effort of UMass Extension, University of Connecticut Extension, and University of New Hampshire Extension, and they are sponsored by Sungrow Horticulture and Blackmore Company. The theme for the webinar series is Growing Healthy Roots. And the title for the webinar today is Growing Strong Roots from the Start. And our speaker is Dr. Roberto Lopez from Michigan State University. If you have any questions during the webinar, please type it on the question box. At the end of the webinar, Rosa Lodales will read the questions and Roberto will provide the answers. After the webinar, there will be a short survey. Please complete the survey before exiting the webinar. Now at this point, I'm going to pass the controls to Roberto to continue with the webinar. Roberto, it's all yours.
Okay. Well, good afternoon, everyone, and thank you to Jeffrey and Rosa for inviting me today. So give me a quick second while I change these settings. Okay, so hopefully everyone can, I think my webcam is on, I believe so. Is that working, Jeffrey?
We just have a black screen on your webcam, but we can see the slides well.
Okay, give me a second here and try. Huh, it's not working. Well, that's okay. I guess I will, let me try one other thing. I guess we should have tried this earlier. Okay, well, as Jeffrey said, today I'm going to be talking about basically growing healthy roots. So we're primarily going to focus on lighting just because of the short duration of time that we have. And I want to briefly cover a few terms. And one term that we often use in the greenhouse industry is daily light integral. And this basically describes the cumulative amount of light. So basically the photons of light, as we can see in this figure, that a plant receives over the course of one day. And with daily light integral, it's basically 1 square meter. So it's basically that cumulative amount of photosynthetic light that falls within this square meter. And this daily light integral concept is really important, and we're going to talk quite a bit about it today and how it really affects the production of roots with both plugs as well as liners. So in terms of propagators of young plants, you're ultimately interested in minimizing production time, right? For seedlings as well as for rooting of cuttings. This is actually a picture that I took in the Northeast. So again, very similar to Michigan. When we have peak young plant production, we have very low light levels. And really our overall goal is to really increase that plug and liner quality and reduce that production time. So during this young plant production time, especially during the peak, our daily light integrals outdoors range anywhere from 5 to 20 moles across the northern US. And of course, once we move into a greenhouse facility, light levels can be 50% or less of outdoors due to the structures, glazing material, shading, and other obstructions such as hanging baskets. Therefore, it's not uncommon to have daily light integrals of anywhere from 2 to 5 moles, and even lower during extended periods of cloudy weather. So when we think about young plant production, we have two sets of graphs. So the graphs on the top basically are showing us our outdoor daily light integrals during peak young plant production time. So if we look at the Northeast in January, our daily light integrals outdoors range anywhere from 10 to 15, and by March, we're up in the range of 25 to 30 moles. Now, as I said, once we move into a greenhouse, we can cut those levels anywhere between, let's say, 50 to 70%, depending on the greenhouse structure. So when we think about the benefits of supplemental lighting, January, February are definitely large benefits. Then once we move into March, those benefits become more moderate. So let's first look at supplemental lighting during liner production. So this is, of course, rooting of cuttings. So in terms of light, diffuse light is obviously best. Indirect light it also works. So how can you do this? Well, you can use whitewash, or if you have some sort of retractable shade curtain, that works really well. You want to avoid obviously excess shading during the winter months. So oftentimes, we have energy curtains, and we can use those energy curtains to obviously help us maintain our temperatures. But by using them, we really reduce our daily light integral, and that can be detrimental to the rooting process. So these are some general recommendations. Of course, some species differ, but initially from stage 1 to 2, so from basically stick to callus formation, we want to provide light levels anywhere between 600 to 1,000 foot candles, or between 120 to 200 micromoles. So this is going to, during this stage, basically provide a daily light integral of 3 to 5 moles of light. Once we start the rooting process, so in stage 3, we obviously want to start increasing our overall light levels. So trying to achieve anywhere from 1,000 to 2,000 foot candles, or 200 to 400 micromoles. So this is really when we want to use that supplemental light, because as I said, we can have daily light integrals that are quite low. So during callusing, 3 to 5, but once we start initiating roots in stage 3, we want to increase that daily light integral from 5 to 8 moles. So this is really when supplemental lighting is beneficial. As those roots start to develop, again, you want to increase your daily light integral between 8 to 12 moles. And then during the toning stage, or stage 4, after the roots have filled half the cell or the liner, again, increase your daily light integral, 25 to 4,000 foot candles, or 500 to 800 micromoles, which is going to give you a daily light integral of 10 to 15 moles of light. And these recommendations are really to produce a high quality liner. So if you have the ability to increase your daily light integral, a little bit above what you're receiving from the sun, that's going to be beneficial. But these recommendations are really to produce a really nice high quality liner that you're going to be able to get out of the greenhouse as quickly as possible. So here I have 2 examples of greenhouses that really have nice systems of being able to modulate light during propagation. So you can see that in this greenhouse they have supplemental lighting. So during stages 3 and 4, they can really increase that daily light integral. But let's say that there are days when the sun is out, and especially during callusing, they have these retractable shade curtains that can also be used. So again, these are great methods of modulating the light, so you don't stress the cuttings, but you also don't delay the rooting process. So how can you measure light in propagation? Very few growers measure light, but it's obviously very important. So here we're basically using a handheld light meter. And with the use of LEDs, it's really important that if you are utilizing LEDs, that you have a light meter that can actually take the correct and accurate readings. So that's one thing to ask the manufacturer. There are other methods of, so this is basically going to give you an instantaneous reading of light. There are these data loggers that also have a light sensor that can be placed in propagation. But again, these are not calibrated for use under LEDs, so you'd have to use a quantum light sensor, which really we're not going to cover today, but we have articles in our MSU website that'll point you to that you can read about quantum light sensors. So in terms of methods of increasing the daily light integral, we've talked a little bit about supplemental lighting, but really, obviously, the light that we get from the sun is free, and we want to obviously utilize as much of it as possible. So how can we do this? Well, by minimizing those overhead obstructions, such as hanging baskets. Obviously, we don't recommend having hanging baskets over young plants, but we often see this. There's obviously problems with potential of disease, but also dripping. Another really important and easy thing to do is making sure that your glazing material is clean. So taking off that whitewash, dust, or algae, and also replacing that glazing material as it ages. considering a glazing material that diffuses light more evenly and distributes the sunlight across the crop is also going to help. And of course, really the greatest increase in that daily light integral is going to come from supplemental lighting. So what are some of the benefits of increasing that daily light integral? Well, at least for young plants, we're going to see, I shouldn't say just for young plants, but some of the benefits, especially for young plants, are you're going to have smaller and thicker leaves. So obviously we don't want young plants that are going to have large leaves that are going to be shading their neighbors and then lead to that shade avoidance response and obviously stretch. We also find that when we increase that daily light integral and we transplant those young plants, they actually tend to flower faster. And this is especially the case with high pressure sodium lamps because they provide additional heat, and so there's an increase in plant temperature. We're going to see more branching, so increased branching, increased stem diameter. Plant height can sometimes be reduced, and obviously what we're focusing on today is increased root growth, and you can definitely see this in this example with these salvia plugs. So this plug was grown under a daily light integral of 3 moles of light, and this plug was grown under a daily light integral of 8 moles of light. So again, you see the overall increased quality. And of course, this plug on the right is going to be finished much quicker. So now let's look at some effects with of cuttings. So here we have New Guinea Impatiens, and this photograph was taken 16 days after stick. So we can see the daily light integrals that we would achieve with just sunlight in a northern latitude. And again, very low daily light integrals of 1 to 4 moles of light. Then we have daily light integrals from 6 all the way up to 11 moles of light. And at the bottom, we can see that root dry mass. So basically what we do is we harvest these cuttings and we take off the roots and we weigh them, or excuse me, we dry them down and then weigh them. And obviously this is a good method of quantifying the number of roots. And as we increase that daily light integral, we obviously see a very dramatic increase in that root dry mass. So what we find is, for example, with New Guinea Impatiens, if you grow these New Guineas under these very low daily light integrals, it could take you anywhere from 5 to 6 weeks to root the crop. But if you provide supplemental lighting above 6 moles of light, you can root the crop in as little as 3 weeks. So basically with New Guineas, you can cut off almost 3 weeks of production time and increase the overall quality. Here's an example with Argyranthemum. Again, we see as that daily light integral increases, especially with supplemental lighting, in this case high pressure sodium lamps, we see a very large increase in that root dry mass, and again, a reduction in overall propagation time. So this crop, or this photograph, was taken 21 days after stick. Okay, so let's move on to Angelonia. So the Angelonia is actually a species that is not as responsive as the 2 previous ones. So with Angelonia, we see that right around 6 moles of light, we don't see a lot of increase in root dry mass. So again, it is very species specific, and if you'd like, I can provide you some examples of crops that we have found that are very responsive. So ones that I would definitely place under supplemental lighting, and Angelonia is one where if your daily light integral in your greenhouse is 4 to 5, then that should be adequate. Providing supplemental light is really not going to obviously increase your root dry mass a lot compared to the other 2 species. Here's another example. So here we're going from very low light, and again, you can see that increasing from 1 mole down to 4 moles and how the cuttings become more compact. You have less stretch and more branching. So again, any additional light quantity that you add is going to improve rooting and overall quality. Here's another nice example, and this is with a perennial. So we see that as that daily light integral increases, not only do we have an increase in rooting and a reduction in production time, but also in uniformity. So look at what happens when we have a very low daily light integral of 1.5 moles of light. We have rooting in some cuttings, but not all of them. So in terms of uniformity, greatly reduced. As we increase that daily light integral by about 3.5 moles, we see that uniformity definitely increases. And again, once we increase that daily light integral further, of course, there are some examples that we can see here where rooting is delayed. So this is obviously a question that we get quite a bit from growers is, you know, the LEDs are becoming quite popular. Are there any additional benefits of utilizing LEDs during cutting or rooting of cuttings? And so here's an example with 2 species. So here we're looking at basically sunlight and a high pressure sodium lamp. And then here we have sunlight and LEDs. So basically increasing amounts of blue light from 0 all the way up to 30% blue. And as we look at these cuttings, we basically see there are no significant differences. So we didn't find any differences in terms of rooting, in terms of overall height, and even when we transplanted them into a common environment, they all flowered at the same time. So at least with cuttings, we don't find any beneficial or detrimental effects of utilizing LEDs. So some of the conclusions that we can take from using supplemental light during rooting of cuttings are that LEDs are comparable to high pressure sodium lamps for providing supplemental light for the calycine, as well as for rooting of both annuals and perennials. So we've done numerous studies and really have found no additional benefits. We've also found that the finished plant quality of most species was not significantly influenced by the supplemental lighting that the young plants received, either from HPS or LEDs. So this is basically our general recommendation that during calycine or stage 2, that you try to target a daily light integral of at least 5 moles of light, having a root zone temperature of around 75, an average daily temperature of 73, and then a vapor pressure, a deficit of 0.3. And again, we move on to stage 3, we double our daily light integral, we reduce our air temperature, as well as increase our vapor pressure deficit. And again, during stage 4, we increase again our daily light integral, reduce our root zone temperature as well as our air temperature, and increase our vapor pressure deficit. And this is really going to help us produce a nice healthy root quickly. Now, let's move on to plugs and show you some of the benefits of utilizing supplemental light during plug production. So generally for plugs, the recommendation is to provide anywhere from 70 to 90 micromoles of supplemental light to achieve a daily light integral of 10 to 12 moles during stages 3 and 4. So very similar targets to cuttings. In terms of supplemental lighting with plugs, again, we're going to get increased rooting, increased stem diameter and branching, and oftentimes earlier flower upon transplant. So one thing that my colleagues and I have found, I'd say in the last year or two, is that some growers are installing these low intensity photoperiodic LEDs. So you can see those right here. These are basically the screw-in LEDs that are replacements for incandescent lamps. So some growers are buying the horticultural ones. Others are purchasing basically LEDs at a big box store. And you know, we've asked growers, why are you utilizing these lights during propagation? And some growers have said that they've noticed that compared to not utilizing light, that they see a reduction in production time by about a week. So we basically wanted to do a study to determine is, you know, we're not providing any photosynthetic light with these low intensity LEDs because the plants are only receiving anywhere from 1 to 4 micromoles of light, which really is not contributing to photosynthesis. It's really only increasing the day length. So I'll show those results a little bit later. So with supplemental lighting, again with plugs, here we have an example of Celosia. I showed you an example earlier. As we increase that daily light integral from 6 all the way up to 16 moles of light, we obviously see that we have increased rooting, as well as a decrease in overall height. Again, this is what a grower would probably achieve. 16 moles of light is quite high. Maybe it's something that you would receive in California or Florida, but again, it's not going to be economically feasible in a northern location. Now, as I said earlier, when we provide supplemental light to young plants, we often find that there is earlier flowering. So let's look at this graph where we're looking at daily light integral during the seedling stage and then days to flower. So as that daily light integral that young plant received increases, we see that that young plant is going to flower faster after transplant. And again, we see that in terms of the number of nodes below the first open flower is obviously going to decrease when those young plants were grown under a higher daily light integral. So a question is, let's say that you are interested in providing supplemental light, but you don't have the capital to install supplemental lighting in your entire greenhouse. Are there any benefits of providing supplemental lighting at different stages during that plug production? So this is a study that one of my colleagues, Eric Runkle here at Michigan State, conducted. And basically what they did is they divided the seedling stage into thirds. Depending on the species, they either lasted 9 or 11 days. So the plugs were provided with supplemental light for 1/3 or 2/3 of that plug production stage, or not at all. So for example, during this first, second, or third, so L basically represents a low daily light integral. So basically what they did is they just provided photoperiodic lighting, or H represented using supplemental lighting to provide a high daily light integral. So in this example here, where we see H, they provided supplemental light during the first, the second, and the last third. So let's go ahead and look at some examples. So here we have Petunia. This photograph was taken 27 days after the seeds were sown. And again, this is basically providing just photoperiodic lighting, so very low light intensity, as we would expect. Poor rooting after 27 days. Now this plug received supplemental light all through the first, the second, and the last third of production. And as we would expect, more leaves, more roots. And again, that's going to be a marketable plug tray much faster. What about only providing supplemental light around seed sow during the middle or during the last part of plug production? Obviously, as we would expect, by providing supplemental lighting during once that plug is much larger, has more roots, it's going to be more beneficial. So again, if you can provide supplemental light during the entire production stage, obviously that's going to be most beneficial. But if you can't, either during the second or last third is going to be beneficial. Here's another example with Pansy. Again, very similar results, where you see a lot of roots when we provide supplemental lighting through the entire production stage or the last 2/3. So here's the study that I talked about earlier with those screw-in low-intensity LEDs. Here we can see basically our unlit controls. So basically this is a Petunia plug with no supplemental lighting. This is after 28 days, or under supplemental lighting from high-pressure sodium lamps. So this is basically providing 70 micromoles of light for 16 hours a day, whether it's sunny or cloudy outside. Now here, we were providing 90 micromoles, again, for during a 16-hour photo period, but only when the sunlight was under a certain level outdoors. So basically only providing supplemental lighting when it was cloudy or during the early morning or late evening. And again, similar treatments, but with LEDs. And the one dramatic difference between let's say the 90 and 90 is the size of those plugs in terms of vegetative growth. So we find that when the daily light integral outdoors is less than 7 moles, LEDs are quite beneficial when you have blue light in being more compact. So again, less growth regulators that you're going to have to use. Now, when we're using those photoperiodic LEDs, those screw-in fixtures, what do we see? Well, we see very large leaves and quite low root growth. Again, those LEDs are providing far red light, which is leading to larger leaves and stem extension. So there's the perception that those plugs are finishing earlier, but really when you look at those roots, they're very similar to the unlit control. Again, here we're looking at Impatiens, very similar. So I'm going to move on quickly because we are kind of running out of time. So basically, with plugs, when that daily light integral is less than 7 moles, at least with these 3 species, we found that under LEDs, they were more compact compared to those grown under high pressure sodium lamps. By providing supplemental lighting, we found that plugs are anywhere from 2 to 4 times, in terms of their quality, it's 2 to 4 times higher under supplemental light compared to growing them under ambient conditions. And plugs can be marketable anywhere from 2 to 3 weeks earlier under supplemental lighting compared to no electrical lighting at all. So in terms of supplemental lighting guidelines, currently the high pressure sodium lamps are still the most economical lamp type for seasonal applications. So meaning if you're only using them for young plant production. Now, LEDs obviously have their benefits, especially if you're going to be able to utilize them year round. So in terms of high pressure sodium lamps, the number of times you turn them on and off is going to affect the bulb. So one way to turn them on and off is if the light intensity is less than 200 micromoles for more than 5 minutes, you can turn them on. Or turn them off if the light intensity is greater than 400 micromoles for more than 10 minutes. And this is a good strategy to, especially with HPS lamps, to really save the life of that bulb. What about intensity and duration? So again, as we increase that light intensity from those supplemental light sources, anywhere from 50 to 100 micromoles, our daily light integral is going to increase. But we see that if we have those lights on for 8 hours and they're providing 50 micromoles of light, they're only going to give us an additional 1.4 moles of light. In order to get nearly 4 moles, we have to run those lamps for 20 hours. When we double that light intensity, we can get up to 7 moles of light. So again, a function of intensity and duration. We actually have a calculator. It's called DLI Calc that you can use your web browser such as Google, and basically Google DLI Calc, and it can help you determine how long you need to run your supplemental lights to achieve a target supplemental DLI, or if you are operating supplemental lights, what is your supplemental DLI? So really the greatest benefits of supplemental lighting are from October to March if you're a grower in the north. We can see that during sunny days, really the supplemental lighting is not going to be beneficial, as we can see here. Let's say our light intensity is 1,000 foot candles and we provide supplemental lighting. So we increase it to about, let's say, 1,200. We see that in terms of photosynthesis, we have a nice increase. Now, if our light intensity in the greenhouse is higher, so if the sun is out, and again, we increase by, let's say, 200 micromoles, we see that our increase in photosynthesis is not nearly as great. So again, using supplemental lighting on cloudy days is most beneficial. In terms of choosing lamps, whether you're trying to select between high pressure sodium and LEDs, there's a wide variety of things to look at. Efficiency, the dimensions and height of your greenhouse, obviously looking at the reliability of the company, the installation and purchase costs, the light spectrum. Situations when LEDs are favorable are when you have high electricity costs or limited energy availability. So again, with high pressure sodium lamps, they utilize a lot of electricity, and so you're going to have more wiring. If there's availability of rebates for LEDs, that can help reduce the costs. Or if there's improved growth characteristics, as I showed you with plugs, or improved pigmentations, or if you're going to use them year round. These are all basically situations when they're more favorable. Again, some of the potential challenges with LEDs are the investment costs. They don't emit heat to the plants below as high pressure sodium lamps do. Durability and reliability, and then some light emission patterns, because those lights are often directional compared to high pressure sodium lamps. So again, I just wanted to indicate that this is a book that just came out this past year that talks more about lighting of young plants and other crops. And Also wanted to mention eGrow, which is a newsletter that we put out. Rosa is part of this, so if you want to sign up, it's www.egrow.org. Again, this is our website here at MSU, which we have a lot of articles on lighting, supplemental lighting. So here's the URL. And again, I apologize, I did run a little over. I can take maybe 1-2 questions if we have time.
Yep. So we have 2 short questions.
Okay.
One of them is, you talked about the screwing low intensity LED lights, and you mentioned that some are horticultural lights were compared to some that are just sold by box stores. So
Yes.
Can you compare the quality of those two?
Okay, so really, the ones that are developed for horticultural purposes, especially when you're growing long day plants. So we know that the red to far red ratio is what induces long day plants into flower. And so if you go to, let's say, Home Depot and you purchase an LED for that's developed for use in a home, they're not going to contain far red light. And so if you're, let's say, utilizing them to induce flowering, you're not going to get that flowering response. So that's really the difference between the horticultural LEDs and those that are sold for consumers. Now, if you're growing short day plants, then you could utilize those. But again, to keep them, let's say, vegetative.
Okay. And then one more question is, what about DLI on seedlings once they have germinated? So I assume something more like for maintenance or promoting root post-germination.
Okay, so I talked mainly about stages 3 and 4 in terms of providing providing supplemental light. So during stage 1 and 2, so during that initial, when the radicle is starting to emerge, and also when the cotyledons are starting to emerge, some growers will provide supplemental light. Again, you don't have to have as high of a light intensity as during stages 3 and 4, but some growers, especially for those species that require light, do provide supplemental lighting.
All right, thanks, Roberto. And
Sure.
then the last question was about whether the webinar will be recorded. So for those of you who are here and those who register, you will receive a link of the webinar later. So thank you for attending, and thank you, Roberto. And please, when you log out, make sure you fill out the survey. Thanks.
And if there's any other questions, you can send me an email, and I'd be more than happy to answer those questions.